Okay, we're back in our stock room. This time we're gonna show you. We're continuing from the string resonance. So this time we're gonna show you sound resonance. We have the sine wave generator. You can see here we used this last time, and we got it hooked up to the speaker. So it's gonna vibrate at a certain frequency, and then we have a tube here. The tube is open at one end here. It's open, you can see it's open at this end, and then as I pull the inner tube out, the effective length of the tube is increasing here. So I'm going to create resonance inside of the tube. So this covers the physics of wind instruments that have one end where you blow air in and the other end is closed, and you create resonance in that. So we're going to start, let's start back here with a length of 0. Put the speaker right here to a frequency of about 210 hertz. 210 hertz, and when you do the physics of this, you see that the first resonance should occur when the effective length of the tube is about 40 centimeters. So I'm going to increase the length of the tube here, as you can see here. Right now it's 10, 20, 30. You could see here we're reaching resonance here. At about 40, the tube is resonating really good with that sound wave. The next resonance should occur at 3 times that length roughly, so about 120 centimeters, because even numbered harmonics are missing for a tube with one open end and one closed end. So n equals 2, even numbered harmonics is missing. So if you go to about 80 centimeters, that shows to you, that proves that even harmonic doesn't exist. Nothing, you see? So it's not just, we're not just saying things, making things up. So the next one is 120. Very noticeable, huh? About 120 there. Resonates really well. So that's known as the second harmonic, n equals 3, second harmonic, and it's also known as the first overtone. That means you have the fundamental frequency, and then first overtone is the next one. Now let's go back down to 0. I feel like a trumpet player here, or a trombone player. Okay, so now let's increase the frequency. Let's say we increase the frequency to roughly about 630, 3 times 210. Or you know what, let's increase the frequency to double 210, that would be 420. It begins to start hurting the ear. So 420. So when should the first resonance occur now? Well, double the frequency means half the wavelength. So the wave is now shorter. So the first resonance should occur half the length of the tube, so that should be 20 centimeters. Close your ears here. Roughly about 20 is the first resonance. Okay, next one. Actually, it was a little more than 20, right about here. About 23, 24 was the first resonance. The next one should occur about 3 times that. So let's go. Twice that, nothing occurs. Roughly about there. Right there. About 55 or so. It's about 3 times. It's actually not exactly 3, huh? It's about almost 3 times the first one. So this is the second harmonic. Go back down, go back down, go back down, go back down. First harmonic would be about 22, 23. 3 times that is about 60, 66. So there it is. It's occurring a little earlier, about 54, 55. Now let's go to something random. So let's go. Let's go down. So I'm at a frequency of now 300. Okay. So at a frequency of 300, then the answer should be in between the two, right? Be in between the 210 and the 400. So roughly speaking, it should be between the 20 and the 40, right? The 20 and the 40. Right about there. 21. Okay. And then the next one. There's a little range there that over which, so I would say about right about 70 mark, okay, is when the next one occurs. So the first one was about 20, 21, 22, 23. The next one was in the 67 to 72 range, with it peaking at about the 70 centimeter, okay. So basically this shows you that the equation is working within a certain uncertainty, having to do with the fact that the tube that we are using is not necessarily a closed tube. I can show you here the end. It's not a perfectly, so you can see here the tube, the sound wave is coming, and you have partial transmission and reflection. So I would say part of the sound wave comes, reflects back, part of the sound wave comes and goes into this secondary tube, and you have other effects going on. So that is what is causing the result not to be perfect, but within a certain uncertainty, it does usually yield us good answers. So we do this as part of our physics labs, and it does usually give us pretty good answers, close to what's expected. Okay, with that we end this. Thank you.